Okay, I did actually successfully get this programmed. Again, there's the chip. It's just got a speaker and an LED and a button. Listen to it now. This should be at 6 megahertz. And that all works, so I'm going to go through the process of reprogramming everything. This is my Arduino. Simple little board. Sitting on the package that it came with, and the only piece of documentation, which basically is just an environmental statement, sort of. Anyways, took out all the programming wires poking up. I'll be putting those on pins 5, 6, and 7 of the ATtiny, as well as pin 1, which is the reset pin on the ATtiny85, to do the programming. I'm going to start. Just got to play this again. So anyways, plays that little tune, Shaven Haircut, 2 bits. It flashes the light. Anyways, I'm going to go ahead and program this thing. All of the internal clock speeds that are available, I actually added 6.4 megahertz. So there should be 1 megahertz, 6.4 megahertz, 8 megahertz, and 16 megahertz for the internal clock on the ATtiny85. And then I will also use the external, nice job with the camera there, the external crystal, which is a 6 megahertz crystal, and that's what I'll be doing. Again, to make the fuse bits change using the Arduino IDE, you need to change your boards file to look something like this. I had been making changes to the FCPU line, but you need, actually there's more involved in that. That may have some effect, but I need to kind of figure out if that's the case or not. So in any case, you need to change your boards file, add something like this to it. These are the fuse bits right here. You see your low, high, and your extended fuse bits, and the values to set those for. You can get those from a calculator that you can find online. So this is what is currently programmed onto the chip. And to do that programming from the Arduino IDE, you go to your Tools menu and select which board you want to use. So you'll see I've got this nice little list of ATtiny85s on top. Many of those were provided, but I did actually add all of the 6 megahertz external, 2 megahertz external, and the 6.4 megahertz internal. So they are currently untested as of now, but I will go ahead and try them again here. So first you select your board. We're going to go ahead and start with 1 megahertz internal. Then you select Burn Bootloader, which I'm not going to do yet because my programmer is not plugged in. I will do that momentarily. Be right back. Okay, so now my Arduino Uno is all hooked up to my ATtiny85, and I'm going to go ahead and burn the bootloader for... Actually, let's go ahead and verify that I'm on the right board first. We'll go to board. I want to be on the 1 megahertz internal oscillator, which I am. So then we'll just go ahead down to Burn Bootloader and cross our fingers and watch the status at the bottom. So burning bootloader seems to be working. Winky flashy lights are already done. Couldn't even catch that. And you always get these error messages, but that's okay. It programs anyway. So bootloader's done. Now we'll go back and we will say File, Upload, or Upload using Programmer. Either one works just fine. Go ahead and do that. Got compiling. When it's done compiling, you'll see the winky blinky lights on the Arduino. Once they're done, it's done programming, and we can reconnect our switch speaker. All done. So now reconnect our switch speaker and LED, and we'll see what that sounds like. So at 1 megahertz and having burned the bootloader, this is the sound that I get when I run my program. and the response. So that's pretty fast. Now we're going to go ahead and step up the line and go to the 6.4 megahertz and see how all that works. I won't bother recording the programming process. It's the same for all the boards. I'll just go ahead and record this so you can hear the sound difference in the frequencies of the clock. Okay, this is the result of burning the bootloader with the 6.4 megahertz internal oscillator. I'm not sure that this is actually correct. It may actually have, the fuse bits might be set to divide by 8, so I'm not sure about this one. This just doesn't sound right to me. Keep the button pushed. That's the... Okay, let's try the 8 megahertz internal oscillator next. Okay, this is with the 8 megahertz internal oscillator. And that's what we got. That's kind of what I expected from 8 megahertz. So that's what that one sounds like. We'll go up to 16 megahertz internal oscillator next, if I could say that properly. And here we go. Okay, now this is 16 megahertz internal oscillator. This is exactly what's expected. It'll go kind of crazy. Okay, and it just... There we go. That's kind of what I was expecting. So, in any case, that's what we get from that. Okay, now this is the 16 megahertz internal oscillator. It kind of goes a little crazy, so I'm not going to do it for too long, but the frequency is definitely higher. So there we go. It's almost too fast. It's almost too fast to see the LED blink. It just kind of made the chip go bonkers, so I had to reset it. But there we go. Nice, huh? Okay, so that's clock speed's way too fast. So now we'll try the 6 megahertz external clock. And then we have our 6 megahertz external crystal connected between pins 2 and 3 on the ATtiny, and it's just about right. So that's what we're expecting. So I think that programming the fuse bits works just fine from an Arduino if you know how to do it. That's all, folks.